it kind of conforms to the edge of the door to create an air seal. And we can put those on 3 sides of the doors. We can have them on the stiles, the lock style, the hinge style, and we can even have one in the transom bar, the header, to seal across the door. But that's only on 3 sides, isn't it? Mm-hmm. Okay? If we put the sweep on the outside, look at the disconnect that we've got between the sweep on the underside of the door and that bulb. So this is all still wide open underneath the door and free to allow air to flow underneath the door into the entrance area of the building. Okay? We put the sweep on the inside, and now what have we got? We've got an effective air seal all the way around the door. Okay? That's gonna, again, this is not probably, in my estimation, I don't wanna, let me rephrase that. I don't want to tell somebody or lead them to believe that by putting the sweep on the inside that their door won't leak. But I think it's less likely to leak and less likely to maybe not leak as much by having the sweep on the inside, because you're reducing airflow around the door. Okay. Now, if they got water raining on the transom and it's dripping off the transom bar and getting into the top rail of the door and leaking down the sides, there's nothing that's going to stop that. Okay. But we want to have the doors as weatherproof as possible, and that's where putting the sweep on the bottom of the doors is the best way to achieve that on the inside. Okay. Now, is it okay to have a sweep on the outside?
Double sweep?
Yeah. Anything wrong with that?
Nope.
No, man.
It's like shit.
That's what they want.
Exactly.
Like shit.
It does. He said it very well.
Been doing it for years.
What he said is the aesthetics are not great. No, what he actually said, he said it looks like shit. Okay, but with that, a lot of times, especially with your storefronts and your entrances, that's creating a first impression to your business, and people want them to look as good as they can look. And certainly, the aesthetics of having a sweep on the outside of the door are not great. But I was telling the guys yesterday, one thing is we want you to put the sweep on the inside, okay? And what usually happens is you put the sweep on the inside and somebody belly aches about it because they think that putting the sweep on the outside is going to make the door waterproof, right? It's not going to. My recommendation would be put the sweep on the inside, and if they want you to also put a sweep on the outside, we can do that. And it'll only cost you $250 per door, right?
I like that answer.
We've got the manufacturer, Bart Harrington down in Atlanta, says that the sweep needs to be on the inside, and so that's the way we install it, right? We use water deflectors. We install our door frames level. We do all of these things. So we put the sweep on the inside. Now, if you want the sweep on the outside, we can do that for a small additional fee, right? And I don't know how much the sweeps cost. Well, the last time I was here, somebody told me they're only like $10,
I don't even think
right?
Our cost.
But you got to mark them up, right? And you got the labor to get it to the job site, the labor to install it, the screws, all that stuff.
Sounds fair.
Yeah. Okay. So that's being facetious, but that can be a real thing. If you think about $10 for the sweep, maybe $100 to put the whole thing in. Whatever the hell, I don't know what your markup is, whatever it is. But that's for every door on the building, right? And that can be a lot of doors. So that's not a sneeze out amount of money. Okay. Closers. The closers that we use in the nurse. What kinds of closers do we have?
1601.
No, not the brand. What kind?
Surface mounted.
You have surface mounted closers. What else?
Concealed closers.
Concealed overhead closers. What else?
Operators.
What's that? Well, you guys have the Stanley doors, right? Typically, we don't like have any kind of standard automatic operating hardware. People attach it to our doors all the time and so forth. But the other type you might run into occasionally are floor closers, right? Anybody here ever put one of those babies in?
Yeah.
Okay.
Take it more out.
So I'm not going to spend a lot of time talking about closers, but what is this thing right here? Does anybody know what this is?
Instructions.
Instructions. Geez, you know, when you guys open up the box that the closer's in, that white thing that flutters away in the wind, those are actually the instructions on how to install these things.
Real
Okay?
big in there, right?
Yeah. So you can see they've got templates in there for mounting these things. And I know you guys install closers all the time. And if I did nothing but install surface mounted closers all day, every day, I would probably tend to ignore these things too. But that's the purpose of me being here, is to share information with you. So this is just, you know, if for no other reason, you know, it probably would behoove you to occasionally take a look at these things just to make sure that you haven't fallen off the right track, and that you are installing them the way the closer manufacturers want them installed, in terms of the layout locations and the distance from the edge of the door to the edge of the mounting template for the closer. And then also information for how to adjust the closers too, because most of these commercial grade closers that we have are adjustable, right? As you can see right here, that's what this is showing here. This one is an LCN 4040. Do you guys install a lot of those? Yeah, that's a very popular closer. Does anybody know what our standard YKK closer is? Anybody?
No.
No? I think it's a Hager. Okay? And I think that's our standard continuous hinge too. So our standard surface mounted closer is a Hager. And then our standard overhead concealed closer, does anybody know what that is?
CFC.
Does anyone know what the brand is?
Well, there's different brands.
Well, the brand that we provide as standard is called Caliber.
Okay.
And it's very much like the International or the Jackson type closers. Very, very much the same thing. It's a clone of those, basically. Okay. But these commercial grade closers are adjustable for sweep and latch speed. Okay. And let's hold off on talking about that for just a minute. This is just showing. This is an excerpt from our installation instructions showing how our concealed overhead closer gets mounted into the transom bar door headers. Okay. But in terms of the adjustment of the closers, whether it's a concealed overhead closer or a surface mounted closer, commercial grade closers are universally adjustable for sweep and latch speed. Okay. So this is demonstrating the swing of the door. Okay. So this down here ultimately would be the closed position. And when we open the door, that's the fully open position. That's all the way up here. What are door closers supposed to do? What is their function?
Close the door.
To close the door. What else? Anything else?
Limit
to stop it from flying open. So it's primarily to return the door to the closed position after you're done operating the door, but also it needs to be able to hold the door closed against wind and stack pressure. Okay, so when we talk about wind on buildings, I think in our minds we typically think about what I described earlier with deflection. The wind is trying to push the glass and the aluminum into the building. Whether it's trying to push the glass and aluminum into the building or whether it's trying to suck the glass and aluminum out of the building depends on what direction the wind is coming from. Okay, because if you're talking about this side of the building, the wind is blowing, it's going to be a positive force trying to push the metal into the building, metal and glass into the building. But as that wind wraps around the building on the sides, it becomes a lateral force that's trying to suck the glass and aluminum out of the building. And the same thing on the back side. You end up with more areas on the building where you have a negative wind load than a positive wind load. Okay? So that's from a structural standpoint on our storefront curtain wall mullions. We have to take that into account. But what effect does that have on your doors? Well, anywhere you have a negative wind load, which is going to be most of the building, you're going to have the wind trying to pull the doors open. So it's not enough that the closers have to be able to return the door to the closed position after they've been operated, but they also need to hold the doors closed when you have negative pressure trying to pull them open, or something else called stack pressure. Who knows what stack pressure is? Anybody? Elevators going up and down an elevator shaft, they're displacing air. So the elevator goes up, it's pulling the air up. when the elevator comes down, what's it doing? Pushing the air in front, and it can come out into the lobby and cause. So closers have to be able to hold the door shut for wind and stack pressure, as well as returning the doors to the closed position. So the doors are adjustable. For right now, what we're talking about is just the swing of the door, the operation of the door. So when you open the door to the fully open position, that's up here at position number, that's from here to fully open. When you release the door from that position, it starts to close. And from the fully open position, and the fully open position it can vary depending on the type of closer you've got. Usually it's anywhere between 90 and 105 degrees, right? So if you're actually ordering closers, like you go into a closer order sheet, like in our price book or something, you can order the closers with a 90 degree or 105 degree open, okay? Why might that vary? Well, if you have a wall right here, you might not want the door to open more than 90 degrees. On the other hand, if you want a bigger, clear opening width, and this is open, you may want it to be able to open to 105 degrees. So it's strictly a location preference that somebody might make, okay? But when you open it to that fully open position and release it, this from the fully open position down here to the last 10 or 12 degrees or so, we call that the sweep speed. And that speed is adjustable. The last little 10 to 12 degrees is what we call the latch speed, okay? Now, why are they adjustable like that? Does anybody know why we need to adjust those?
Door don't slam.
Well, ADA might be part of it. Has you guys ever had an inspector out there timing how long it takes your door to shut? They do that, okay? You'll typically have a code compliance officer come out, and they'll open the door, and they'll let go of the door, they'll hit a stopwatch, and they'll see how long it takes it to close, okay? What do they want? Does anybody know what that time is? 6 to 7 seconds. Yeah, it varies. You know, different locations have different, speed requirements. Typically, I see it anywhere from 6 to 8 seconds. Okay, it just kind of varies depending on the area. So what he'll do is he'll come out, he'll open the door, and he'll say, okay, that only took 5 seconds. You need to slow that thing down. Okay, so on the closers, there are adjustment valves. And you can either speed up or slow down the sweep of the door by turning those adjustment valves. And it's a trial and error thing. You can open the door up, turn the valve, maybe give it a half a turn, let go of the door. If that doesn't do anything, maybe you give it a full turn, whatever. You just kind of wait till you find that sweet spot for the proper sweep speed. The latch speed, we want the latch speed to be a little bit more aggressive. Okay? We want the door to slam just a little bit. Okay, when I say slam, that sounds like a harsh word, but we want it to close emphatically. How's that? That's maybe a better way of putting it. Why is that? Why do we want the door to slam just a little bit? Yeah. Well, first of all, we've got those rubber gaskets around the doors, right? And we want to make sure that the door seats firmly into those gaskets. So that's one reason for wanting to do it. The other is some of our securing hardware, like rim panic devices, latch locks, concealed rod panic devices, are the actual activation of the securing hardware requires that the door close with enough force for that to trip. Okay? So if for example, if you have the door adjusted so it closes very slowly and very gently, it might not want to lock, and it's probably not going to seat into the gaskets. So typically what you're going to want to do is speed up the latch speed relative to the sweep speed so you get that little slam at the end. Doesn't mean you want the whole wall to shake or people in the building to be annoyed or anything like that, but it needs to be able to close with enough force to secure the door. And I get a lot of phone calls like that. Hey, these clowns came in and installed your doors and they're not locking. The door closes and it's just like it's closing too softly. Well, hell, that's an easy thing to fix, isn't it? You take the cover off of that surface closer and you find the little valve that says L on it, and you turn it in the plus direction and it'll speed up that latch speed, and you should be good to go. Okay? So adjustable for sweep and latch speed. What this is showing here, what is here for number one? It says back check. What is back check?
How heavy the floor is though.
How heavy it is to open?
The resistance for the end up as far as it can go, like the 105.
You're sort of right. You're correct. So what back check is, and you'll feel this, it's something that you feel, and again, closers come either with or without the back check feature, or I'll show you in a minute a diagram. I actually saw a closer that had an adjustable back check, which I thought was a nice feature. At any rate, what the back check is as you open the door, as it gets closer and closer to its fully open position, you start feeling resistance from the closer, okay? And what that's for is to, if you have, for example, a wall back here, say this is an interior application and people are walking through this door, if they're pushing that door open, they can push it with enough force to where it'll bang into that wall. With a back check in there, it kind of creates a cushion, hopefully to prevent that, okay? And again, it's typically to either protect conditions on the back side of the door when it's fully open, or possibly even just to protect the hinging hardware and things like that, because certainly you can open a door far enough to where it can damage your hardware, correct? Okay. Is a back check typically going to be strong enough to protect a door when the wind grabs it and jerks it open?
Back check? No.
I've never seen a closer with a back check strong enough to do that. Okay, they do make items of hardware that you can put on as additions if you have a condition where you have a wind problem. Okay, things like I don't know if you've ever seen them before. They might have what they call a floor stop, right? It's something you drill a hole in the concrete, you screw those floor stops in. It's got a rubber bumper on it, and when the door opens, it hits that stop. And so, like in this particular condition here, you'd put it right here if there was a wall or something that it was banging into. Okay, but the problem you have is it is also a tripping hazard, and you can't put them in areas where you might get foot traffic. So, for example, if this was just a sidewalk out here, okay, and people might be coming up to the doors from any direction, you can't just put a floor stop out in the middle of an area where a pedestrian might trip over it. So you kind of have to use a little bit of thoughtfulness. Somebody says, "Hey, we keep breaking hinges, or we keep breaking closer arms, or we've got closers the oil's leaking out of them because the wind's grabbing this door and pulling it open." You can't just go in and screw down a floor stop and be done with it. You have to kind of be thoughtful about it. Are there other items of hardware you can put on a door to prevent overswing?
Concealed overhead stop.
Yeah, I saw one. I think in the men's room here, there's a door that goes the other way, and they actually have one mounted onto the top of that door. A Glenn Johnson is the brand. It's called a Glenn Johnson door holder, which basically all it is. It's a long, thin box. It looks like a box, and it's got a really, really strong spring in it. And what it's doing is it's creating a cushioning for the door. So a lot of times those can be used in conjunction with the closer to control the swing of the door is what we're talking about doing. So, for example, if you have a surface-mounted closer, you can either mount the Glenn Johnson on the top rail of the door instead of on the transom bar, or they have ones that can be concealed inside the transom bar or the header. So there's a variety of them. So that's it. Back check, sweep speed, and latch speed. Okay. This is the overhead concealed closer. Again, the brand that we provide as standard is Caliber, but it's basically a clone of the Jackson International. I think C.R. Lawrence has got one very much like it. I don't know, to be honest with you. I couldn't speak for if any one of them's better than any other one. They all look the same when you take them out of the box. But these little screws right here, those are the valves for adjusting sweep and latch speed. Okay. When the closer is installed in a transom bar or header, there's usually an oval or a square cutout in the cover plate for the door that gives you access to be able to reach up and adjust those screws. Okay. Any questions about that? Do you guys install a lot of concealed overhead closers around here?
Yes.
You do. All right. How well do those closers work when it gets real cold outside? You ever have problems with the hydraulic fluid getting a little thick?
They act up sometimes. Usually when they're brand new, and then when they're like sitting in the van or whatever, or
Yeah.
truck for a long time.
Yeah, like up in Chicago and Minnesota, very rarely do you see these used on exterior doors. It gets so cold, the hydraulic fluid, gets thicker and thicker, and it makes it tougher for the door to operate properly. Okay, this is just I was telling you about. This used to be our standard overhead closer. It was made by a company called Dorma. I just included this diagram just to show you something else. They're just showing on the body of the closer. At this end of the closer, there's two valves for adjusting the latch speed and the sweep speed. And then on the other end, you've got actually an adjustable back check, which is, I think, kind of a nice feature. What is, anybody tell me what DA is?
Delayed action.
Very good. Not a lot of people know that. What is delayed action?
It'll hold itself for a couple seconds.
Yeah.
Before it starts to close.
Yeah, so delayed action, which I think is a cool feature too. Usually when you have a closer, or you have, whether it's a surface mounted closer or a concealed closer, we have an option for something called a hold open, right? If you have a concealed overhead closer, the hold open, you have to order the closer either with or without a hold open, okay? And the closer is provided. So for example, if you order a closer with a hold open and then you decide you don't want it, you have to change out the closer. You have to take the door down, take the closer out, put in a closer that doesn't have a hold open. The surface mounted closers, there is no such thing as a hold open surface mounted closer. What we do is we have different arms that we use with the closers that create the hold open feature. And so if you install a surface mounted closer with a standard arm that doesn't have a hold open and they decide they want the hold open, all you have to do is disconnect the arm and put the hold open arm on. Okay? What we're talking about here though is sort of something different than that. The delayed action is a feature that allows you to, when you open the door will stay open like a hold open for a period of time before it begins to close. Okay, I would think that would be something really good in like an old folks home, like where my mom lives, or if you have any type of facility where people are moving a little slower, like a lot of handicapped people or a hospital or something like that. And of course, you can adjust how long the delayed action is by adjusting that fastener or that valve. Okay, what's this for?
Spring tension.
Yeah, do you need to be screwing around with that?
Depends on you.
I hope not. Okay. Again, is it possible to put this too tight or not tight? Yeah. You want to know if you're going to be changing the spring tightness, make sure that you're doing that properly or you have training on how to do it, because I've seen people get injured by those. Okay. But what this is all about is how much force it takes to open the door. Okay. So like, for example, if you've got a problem with the wind pulling the door open or a stack pressure pushing the door open, you can tighten this up to tighten that spring, okay? But also be aware that there may be code restrictions on how tight you can make that, okay? Again, this is not an ADA requirement, because the ADA does address closer opening force, but they only address it in terms of interior doors, okay? Exterior doors is usually a function of local codes. And so it's going to vary from one municipality to another. But they may have a requirement that it can take no more than 8 pounds of force to open the door. But if you've got a real problem with stack pressure or wind pulling the door open, then they have a choice. They can either be compliant with the code, or they can, allow you to adjust it to where the door stays shut.
Selling an auto operator.
Or selling an auto operator. Hey, there you go. You guys can do that now, can't you? Are you guys installing Stanleys, or do you have a separate crew that you do that? Okay. How are you liking that?
It's all right.
Is it a lot of service work?
As of right now, it's mostly service.
Yeah.
We just got certified back in July.
Yeah.
So, but we were doing the what are they? Not the Norton 6300s. We've been doing them for a while.
Okay.
The low energy, mostly all low energy. We're just getting into the high energy.
I gotcha. Yeah, I've always imagined that automatic operators would be a never-ending service battle.
They're not too bad.
Yeah.
It just depends on the usage.
Yeah. I think it used to be worse. I know that when I was a rookie sales rep at Conair, the old dinosaur guys were still bitching about. Apparently, in the 60s, Conair took a shot at having an automatic door. Okay, I think one advantage that we have now is that most automatic doors are sliders. Back then, they were swingers. And boy, those mechanisms broke down a lot. And the sales guys hated them because if they sold a job, they ended up spending more time servicing those things than they did actually benefiting from the sale. So that's interesting. Okay, here's the adjustment instructions for the LCN 4040. This is just something else I wanted to show you. This is a unique, well, not so unique, but it's a specific product combination that I want to show you something that happened on this. So what we're looking at here, does anybody know what this is right here?
Curtain wall.
Yeah, this is our YKK 750 OG curtain wall. That's a typical vertical mullion. It's showing it as a jam condition, but that's a typical vertical mullion. Okay, what's this right here?
Door.
So it's our old thermal door. We have a new thermal door now, but this is the old one. Okay, what the hell is this?
Subframe.
That's what we call a subframe. So when we're installing a storefront door into a curtain wall, we have to create a door frame for that door, and we do it with what we call a subframe adapter. That's this portion of it right here. What's this thing? Continuous hinge, right? Roton is a brand. Okay? A lot of people call them, all of them, Rotons because that was like the first popular brand, kind of like a Xerox or a Kleenex. But yeah, it's a continuous hinge, okay? So what you'll notice here is the actual door frame itself is mechanically attached to the curtain wall mullion. Do you see that? Okay. What is this right here? Just this. Does anybody know?
Looks like an adapter.
It's the door stop. Okay. It snaps. It snaps into the door frame, and it provides the stop for the door, and it conceals the fasteners where you're attaching it. Okay. I'm just explaining to you what you're seeing here. Okay. So we had a project. This was several years ago, and I happened to be in I don't know, Baltimore or DC. This particular job was at American University in Washington, D.C. They said, we're having some problems with the doors. Do you have time to run by the job site and take a look at it? I'm like, I hate going to job sites and looking at doors, but yeah, I'm here in town, so I'll go look at it. The problem that they were having was that this was a pair of doors, and the doors were rubbing in the middle. Okay? And so the customer, and they had a couple of theories as to what they thought the problem was. They thought that the doors maybe were expanding and contracting enough to where they would rub in the middle, or maybe that the doors were manufactured the wrong size. That instead of being, of a certain size to fit into the door opening, they were of a certain size plus. And so I'm like, I'm just looking at it. I can see that the doors are rubbing, and I can see where it's rubbed the paint. These are painted doors where it was rubbing the paint off the doors. And I'm kind of looking in general at the way they're installed, and I'm checking to make sure the frames are all plumb level and square, and everything looks good, all the normal stuff that I look at. So I get out my tape measure, and I measure the door opening, and then I measure the door leaves. And then I call down to our manufacturing, and I get our product engineer on the phone. And I said, hey, I got a door opening of this, and I've measured the door leaves. I just want to make sure that we made them the right size. And they did the math, and they said, yep, A plus B plus C equals D. And I said, why the hell are these things rubbing in the middle? It didn't make any sense to me. So I didn't have an answer for the customer that day.
They didn't deduct for the hinge.
What's that?
So they didn't deduct for the hinge.
No. I told them everything. So I kind of wrote some notes down and took some pictures and stuff like that. I told the customer I'm gonna be back in the office next week. I'll get some other people on the phone, and we'll kick this around, see if we can figure out what's going on. So I get back in town, and I'm on I'm on the YKK AP Quality Conformance Committee, so I attend these monthly meetings where all the different manufacturing and product engineering, everybody gets together, they talk about, quality problems that we run into and what could cause them and how do we fix them. And I'm just sitting there, I'm thinking about this, and I'm probably going to ask the group about it, but I'm listening to people complaining about, oh, well, we had a window job and we forgot to do this, or we did this wrong, or whatever, blah, 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 blah. So somebody finally goes, Bart, you got anything for the group? I said, yeah. And I started showing the pictures. I said, I got these doors, they're rubbing in the middle. The frames are installed plumb level and square. The doors appear to be the right size. I just can't figure out, why they're rubbing in the middle. And this one guy sitting in the back of the room that always came to these meetings, never said a word. He goes, is this installed in a curtain wall? I go, yeah. He goes, is it the XT doors? I go, yeah. He goes, has it got that subframe in it? I go, yeah. He goes, has it got continuous hinges? I go, yeah. He goes, I can tell you what the problem is. So look at this. See these? What are these things here?
Short screws for the continuous hinge.
Yes, so those are the screws that come with continuous hinge. Those are kind of fun screws, aren't they? Because you don't have to drill any holes, do you? Why is the end of it bald like this? They're self-drillers, right? Self-drillers and self-tappers, which is a cool screw. So when you buy the hinge comes with, I don't know how many of them it is. What's that?
2 bags of them.
2 bags of them, however many's in a bag. There might be 20 of them in a bag, And so you attach the hinge to the door, and then you attach the other side of the hinge to the frame, okay? The problem is, look at this right here. With the screws that come with the hinge are this long. So when you run them through over here, they're attaching to this, but they're not really attaching to this. This is the meat over here. That's what we want them to be attaching to, but all they're really attaching to, now these are, because these are longer ones. Notice that these are longer, okay? So, but these are the ones that come with the door. So he says, yeah, what's happening is them screws, they aren't going into this. They're only going into this. So when you open the door, this little thin snap-in piece is doing what? It's bowing out, and when it bows out, it's allowing the doors to rub. Okay? So I called the customer. I'm like, oh, shit. Okay, I get it. I see what the problem is. So I call the customer up, and I tell him what the problem is, and he's looking at the details. He's going, oh, okay, I see. I get it. And so he orders some more of these long screws. He orders some of these long screws and goes out and has the guys run the screws back through. And now he goes, oh, yeah, they're working real good, but we got another problem now. Yeah, because what those guys in the field did, they took a grinder and ground the edge of the door down so they weren't rubbing anymore, and then touched them up with touch-up paint.
Oh,
and so now when they got the right screws in there, now they got a big gap between the doors. Okay, so at any rate, there's nothing in particular that I'm trying to explain to you about this. It's not like I'm trying to teach you about this hardware combination. I'm just showing you that what we do with doors is very difficult. And the difficulty is we have a number of different frame options. We have a number of different door options and an almost infinite variety of hardware types that we're putting on and combinations. And so, again, these kinds of things, I wish I could say that rarely ever happens. As we get more experience and we're working with better and better vendors, this type of thing doesn't happen a lot. But you shouldn't lose sleep over it when it does happen. Usually there's a remedy to it and we can fix it, okay? But that's just an example. So our remedy to this was that we already had recognized and isolated this problem. And our answer to it was changing all of our details on this to show the longer screw and the shorter screw, okay? The other thing that we did is if we provided the continuous hinges, we broke out that package of screws and we included the longer screws in there, okay? But that's only if we provide the hinges. If they're buying the hinges from a hardware supplier or another vendor, they're not aware of that and they're not getting the right length screws, okay? So that's just some things I wanted to talk to you about entrances and hardware. Do you guys have any other questions or comments about entrances and hardware before we move on?
I had one about if you go back to where you had a slide about CUC, the difference between a was that one? Yeah. So we had a couple problems where we were for an offset pivot. We kept fighting back and forth about where the location should be because on
The location of what?
so if you're doing a offset pivot, your COC can't go all the way back towards the frame. It's going to go farther up. It's going to be because your top pivot point is in that header. Say you're using, instead of a center hung door, you're using a COC with a arm.
Uh-huh.
All right. And then you had to slide it up, and then it was throwing off, or say we use a 90, but because you have to move it forward because of the offset pivot on the top of the frame, you're not getting a true 90.
Are you fabricating the headers yourselves? You getting them from us?
In-house. Yeah. So our option is to go to a 105, but it's still like right at 90 degrees.
Yeah.
If not a little under.
Yeah, I don't know if we when we're fabricating those headers, if we're doing something different for that. I don't know. I can look into that though. Okay.
That was just something that we had problems with before. We don't do it often, but when it comes up, it's a headache.
Okay. Good deal. This is something, and this isn't going to take long. I wanted to talk to you about this before we get into the curtain wall discussion. But this is something I kind of wanted to talk to you about. When we look, at our industry and we look at things that are changing in our industry, in directions that we're moving, going into the future. Some of the things that we're seeing are things like an increased demand for unitization and pre-glazing. Do you guys know what those terms are? So pre-glazing is a way of describing a storefront or a window wall system that instead of just assembling the frames in the shop, taking the frames to the job site, putting the glass in them, you're actually glazing them in the shop, taking them to the job site already glazed, and installing these pre-glazed units. That's pre-glazing. That would typically be for storefronts and window walls. The term unitization is the same thing, but it relates more to curtain wall products, okay? So that means, again, all of this, the assembly, all the seals that we're talking about, all the work with, all of that is done in the shop. And then the material, the work that's done on site is just a matter of setting and anchoring the frames. And there's obviously different anchorage methods than what you're typically accustomed to. So that's something, and again, that's just something that we're seeing a growing interest in the industry. And so the result of that is that we're developing new glazing systems to allow you to be able to do that. If you want to glaze them in the shop, you can glaze them in the shop and take them to the job site. That means you've got a higher percentage of labor that's being done in the shop relative to what's done in the field. Makes it easier to control your quality because you're doing it in the shop as opposed to doing. There's a lot of reasons for it, and so that's one thing that we're seeing in our industry that is growing in popularity. And it's right now it's more on higher end projects. If you ever are in Philadelphia or New York City or one of the places where they're building the real high-rise buildings, you'll probably see these types of things going up. Used to be everything was you put in sticks of aluminum, the entire building would be all sticks of aluminum, and then you'd set the glass, right? Well, now these buildings are coming in and they're erecting them already glazed, and they'll come in and they'll do four floors of curtain wall in one day. The next day, and so they're closing in the building quicker. But that doesn't mean there's not a lot of work being done. It's just being done in the shop before they get it out to the job site. So that's something that is a growing trend in our industry. And so we have, right now, we have 2 window wall products that are pre-glazable. We have a hurricane impact storefront system that's pre-glazable. We have a curtain wall system that's pre-glazable, and we are unitized. And then we also bought a company that does nothing but unitized curtain wall work. It's a company called Erie Architectural Products. Anyway, that's all they do is big high-rise unitized curtain walls. The other thing that we're seeing a lot of growth in or changes in the technology is thermal performance, okay? Thermal performance in our systems. And so I just wanted to spend a few minutes kind of going through a little bit of the science behind thermal performance, just for your own personal interest, education about how these things are done. So in our industry, there are a number of organizations that create standards. For mostly for the glass and the window side, you have the NFRC, which is the National Fenestrations Rating Council, and the stuff that tends to apply more to like our stick storefronts and curtain walls and so forth is an organization called AMA, the American Architectural Manufacturers Association. And what those organizations do is they establish what levels of performance have to be met, how do you test the systems to determine whether or not they meet those levels of performance, and other product type definitions that as an industry we all use. And when I say we all, I don't just mean YKK, but everybody in our industry, all of our competitors included, are members of these organizations so that we're all kind of working under the same set of rules, okay? When we talk about thermal performance, we're talking about the movement of air, or temperature is what we're talking about, right? The movement of temperature. And there's 3 basic ways that we move temperature. And this is, by the way, this is, again, basic science stuff. And this is stuff that you guys see on a day-to-day basis. There is conduction, which is the transfer of heat through matter by communication of kinetic energy from particle to particle with no net displacement of the particle. So this is like when you take a spoon and you stick it in the pot to stir the soup, how the spoon starts getting hot. Well, that's the heat conducting up through that metal and getting to your hands, okay? Remember what I said about aluminum. Aluminum is very conductive, isn't it? Okay? So you get a lot of thermal conduction. Convection is the movement in a gas or liquid in which the warmer parts move up and the cooler parts move down. You guys remember that, right? So if you're ever up in the attic of your house in the summertime, the higher up you go, the hotter it is. The lower you are, the cooler it is. That's because the hot air wants to rise and the cold air wants to settle. And it does that continuously. It's a circulation, and they call that convection. And then there's radiation, which means that there is a heat source producing heat, and that heat is radiating off of that source. And the best way of kind of showing that is this diagram right here. So we have the heat source down here, a fire that's radiating heat. That heat is, you've got a pot here. Okay, we're getting some conduction through the pot, but it's causing convection with the water in the pot. That's the boiling that you see when you're boiling water. And then you have conduction, which is the heat transfer through a solid material that makes the handle hot. That's why so many of our pots have less conductive material on the handles, okay? So again, to kind of take this, where I'm going with this is to show you how these factors impact architectural aluminum products. Okay, so take these same things that are going on. We have radiation, we have conduction, we have convection. Radiation, there can be two sources of radiation. One is what? Sunlight, right? Sunlight going through the glass, creating a radiated heat on the inside. We call that solar heat gain. Okay. The other, what else do we have radiating heat on the interior side? What's on the inside causing heat? Yeah, the heater, the HVAC system, right? Okay. Then within the system, okay, so we've got that's the radiation. The conduction that's occurring is the transfer of heat from the inside to the outside. So the hot air on the inside and the solar radiation is warming the inside aluminum, but we're also conducting it through the aluminum back to the outside. And then you have these voids in the framing system where the glass stop is, and underneath the sill and the sill flashing, where you get the air temperature changes causes the air within the system to convect or to move around. Okay, and all of these things have an impact of making the system be less thermally efficient. Okay, and what I want you to notice, a couple of things about this diagram, is you'll notice that there's no thermal break in this system, right? No thermal break. But look at this right here. We have a way of testing the systems, and we can do it. We can do it in actual test chambers, or we can do it with on computers. In this particular case, what we typically do for testing these things is we create a condition where it's 70 degrees on the inside and 0 degrees on the outside. Okay, that's the actual condition that this frame is sitting in. Now, what I want you to look at are the actual surface temperatures of the aluminum. Okay, remember, we have no thermal break. We have 0 degrees outside and 70 degrees inside. So you'll notice here on these near inside surface, the surface temperature is 20.4 degrees. That's pretty cold, isn't it? What is it on the outside? Okay. What's the air temperature outside?
0.
0. Okay, so this is actually warmer than the air temperature on the outside. What's warming that? Not the sun. It's the conduction of heat from the interior to the exterior. Okay? So how do we deal with that when aluminum is so thermally conductive? Well, we have different technologies that allow us to introduce thermal breaks in the system. So this is like the system we talked about this morning, the YES 45TU. Okay? Now look at what we've got. We've still got the sun radiating. We got 70 degrees on the inside, 0 degrees on the outside. Now we have a thermal break. Okay? What's our surface temperature now? It's not great, but it's pretty good, isn't it? Compared to what it was. What was it before? 20, 21 degrees. Okay? But look at out here. 7.5. Okay? Why is it 7.5? Why isn't it 12? Well, because we're not conducting as much heat to the exterior. So this is much more efficient than not having a thermal break. Okay? So it's still 0 degrees outside, but since we're not conducting as much heat through the system because of our thermal breaks, this isn't warming up as much. We're not losing as much heat. We're keeping the heat on the side we want it to be on more efficiently. Not completely, but more efficiently. Okay? You take the same thing. Now this is our XT storefront system. When you see the XT designation, that means there is some feature that gives it better still thermal performance than a standard product. Now look at what we've got. Because we've got a dual pour into bridge thermal break, we've got 40 degrees on the inside and only 6.6 degrees on the outside. So as we're modifying the product, we're making these more and more thermally efficient. We can actually capture this information in terms of measurable values, like we call it CRF and U factor, that are mathematical ways of measuring the performance of the system so that an architect can compare one system to another to make a determination as to which one is more thermally efficient for his building. Okay, and by having a more thermally efficient product, glazing product, then maybe they can spend less money on the HVAC system. Okay, or even if they use the same HVAC system, it'll cost less money to run it because we're not radiating as much cold air into the conditioned space. Okay, so this is again just a little bit of the science behind thermal performance of these glazing systems, and of course, you know, the glass itself has a bigger impact on it than the aluminum does. When you look at a glazed opening, hell, 95% of it's glass, right? A relatively small percentage of it is aluminum. So you're actually going to gain even better thermal performance if you have higher thermal performing glass. Okay? What do they do to glass to increase the thermal performance of the glass? Do you know? What's that? Yeah, they have different coatings that they can put on the glass that can make the glass more or less thermally effective. Some things that you guys ever hear about argon.
Yeah.
They'll inject argon into the airspace between the insulating units. Argon tends to reduce thermal flow. I mean, I would argue my experience has been that I think the argon dissipates after a few years, but it's still, if you're looking for initial high thermal performance, that's a good way to go. There's other types of glass too. There's triple glazed glass that has two air spaces. They have heat mirror, which has a suspended film in between for reflecting more of the solar radiated heat gain to the exterior. Those tend to be better in warm weather climates. Okay. And I'm going to skip off. This is the U factor and CRF. Those are the numbers that are produced from all this testing that, again, gives the architect the ability to compare one system to another. Obviously, one of the reasons we're doing it is to make the building more comfortable for the occupants. Have you ever sat next to a window and it feels like there's a breeze coming through the window? Okay. Have you ever checked to see if there is actually a breeze? How can you do that?
Candle.
You can do it with a candle. You can do it with, there's actually little things that make smoke. You can take a piece of tissue paper and hold it and see if you get air moving. What I have found is that most of the time there is no air movement, right? What it is this is sort of a human physiology thing, is that when you're standing next to something cold and you feel like there's a breeze, what that is that's the sensation of heat leaving your body. And it feels like moving air. Okay, and so I've been to places before where they go, oh, the people that work right next to this window are complaining about air coming through, and I go, there's air coming through the window. Is the window open? No, the window's not open, but they think there's an air leak somewhere. And you can go in there and turn on the smoke machine, and the smoke is just hanging there. It's not moving. Or you can take a tissue and hold it by where they think, and it's not. It's hard to convince somebody. Now, they may very well have an air leak through the window of some type, but more often than not, it is just the sensation of heat leaving your body. It happens to feel like moving air. Okay? So, but a more obvious appearance that leads to the fact, or that's going to lead to the conclusion that there might be a true window performance problem would be the appearance of condensation on these frames, right, or on the glass, okay? And we all know how that happens. That's dew point, right? Once the surface temperature falls below a certain point, given the relative humidity, moisture in the air condenses on the cold surface, okay? So when you see condensation, whether it's on the glass or on the aluminum, is that moisture, is it coming from the metal or the glass? No, it's coming from the air. Okay. Sometimes when we have condensation problems, it's not the fault of the glass or the aluminum. It's because for some reason they have extremely high humidity in the building, and that can be the result of a lot of things. You know, I went to a condo several years ago, and they were saying that they thought they had defective windows in one condo unit. The rest of nobody else is complaining about condensation, just this one guy. And we go in there, and the guy, I don't know what he was. He was a musician or something like that. He had 2 humidifiers going, right? You can go in there and measure the humidity. The relative humidity in most of the units in that building was about 30, 35, or 40%. His relative humidity was up around 60 or 70%. So he's more likely to get condensation just because his humidity level is higher. I've been in places before where they have a humidity problem because the dryer vent was clogged with lint. And so instead of venting all that, the humidity out of the clothes dryer to the exterior, it was rotating right back into the living space. And instead of having a manageable level of humidity in the building, they had very, very cold, or they had very, very high humidity levels. And of course, when you have high humidity levels and low surface temperatures, then you're going to get condensation. And if those low temperatures are low enough, as in below freezing, what happens to the condensation?
Frost.
It turns into frost or ice. Okay? So we limit conduction by adding the thermal barriers. And again, and this is just sort of different types of thermal barriers we've talked about a little bit. This is what we call an Insulbar or Dylon isolator. That's the industry standard for that type of thermal barrier. Does anybody know what the YKK brand name for this is? It's called Megatherm. Kind of like the Transformers, I guess. I'm not sure. Then we have, remember the pour into bridge? We have the pour into bridge thermal brake. Our brand name for that is Thermobond Plus. You also have, in the case of the higher thermal performing products, the dual pour into bridge. That creates a situation where you have much less conduction and convection. And then you guys have probably seen these before. You ever seen the system with the clips? Yes, no, maybe?
Nice letter.
You like them? They actually perform pretty well. The architects kind of like them because you can get different depth covers and different depth mullions, and it gives the architect a little bit of design versatility. Unfortunately, most of the glazers aren't as accustomed to installing them, and they tend not to like them because they're different. Okay. The term thermal break, what does that mean? Okay. Again, AMA and other organizations, industry standard organizations, there is a specific designation of what a thermal break is. And what a thermal break is, it means you have to have physical separation between the aluminum on the outside of the window and the aluminum on the inside of the window of at least, where is it? Is it on there? 0.21? About 0.21 of an inch, or about a quarter of an inch. Okay? You have to have that much physical separation to call something thermally broken. Okay? The other, in this particular case, this is a non-thermal window. And again, this is just showing 70 degrees on the inside, 0 degrees on the outside. This is an actual computer-generated model of the surface temperatures. And notice how gradual it is. Look at how much heat you're losing through this. But it's very gradual. When you get a thermal break in the system, watch what happens to the model. Right? So this is actually functioning as an actual barrier. The other one, there's no barrier. Now we've got a barrier. And you can see how significant the difference is between the surface temperature of the aluminum on the inside versus the aluminum on the outside. Okay? This is the same diagram using the dual thermal break and how much of a difference you get there as well. Okay? The term thermally broken, again, we want a material separation of at least 0.21 of an inch to technically be able to call a product thermally broken. If it's less than 0.21 but greater than a 1/16 of an inch, we call those thermally improved. Okay? It's just a way of advertising your products. Okay? So this particular product is our YCW 750 OG curtain wall. Is this thermally broken or thermally improved? That would be thermally improved. You don't have a measurement there, but that's clearly not a quarter of an inch. Okay? But still, even though it's only thermally improved, we still get very good thermal performance with it. Does anybody know why? How come if it's only thermally improved? Look at this, 49 degrees on the inside. That's better than any of them we've looked at so far. Why is that?
There's not a lot of metal outside the grab heat.
Yeah, exactly. So what you've got here with this type of product is you got a great huge mullion on the inside that's being warmed by the HVAC system and a relatively small amount of aluminum on the outside. So sometimes it's not just whether it's thermally broken or thermally improved, or sometimes it's the configuration of the components in the glazing system that can have an impact on the thermal performance. Okay, this is our highest thermal performing curtain wall system, YKK 750 XT. And you can see, in addition to the thermal improvement, it actually has a thermal break in it. And you can see how much better still the XT curtain wall system performs. Okay, and then these are just diagrams showing different systems and allowing you to compare from one system to thermally broken to non-thermally broken to the XT with the dual pour and the bridge. And the same thing with the curtain wall systems. One thing I'm going to talk to you about after we talk about the 750 OG curtain wall is, have you guys ever seen this before? Well, first of all, what is this right here? That's a pressure plate, right? What's that made out of? So what's this? You guys know? It's also a pressure plate, but it's made out of polyamide, okay? Which is the same kind of material that the Megatherm thermal brake is made out of. So we have an optional polyamide pressure plate. And notice a couple of things about the pressure plate is it's not made out of aluminum, so it's not going to be conductive. And the other thing about it is it has these hollows in it. What are the hollows helping us with? Convection, right? It's helping us with convection. So by virtue of the fact that it's non-conductive and it has these hollows in it, we can do some improvement in our thermal performance just by using the different pressure plate. And you guys actually have a project coming up with this pretty soon. I don't know if any of you are going to be working on it, but I just want to talk to you about the fabrication and installation of that pressure plate, because it's different than the aluminum pressure plate. It's not hard. There's nothing in it that you can't do, but it's different. And I know a lot of times we don't like to deal with different things, okay? This can be a really good product, but if you don't treat it the way it needs to be treated when you're fabricating and installing it, it'll make you unhappy, okay? So I just want to kind of cover that with you. I covered it with the guys that were in here yesterday, and they seem to understand what I was talking about. So I just would rather have you learn it in here and do it right when you install it than call me up down the road if you're having problems, worrying and being upset about not getting the kind of performance you want to get, okay? What's this right here on the inside of this window? Yeah. Say one of the biggest problems we have with condensation is when the architect wants to put a piece of aluminum brake metal under our thermally broken framing system. Okay? What is the purpose behind this thermal brake and the insulating glass? The purpose is to keep the cold air out, right? And keep the warm air in. What's this thing doing?
Bring it right in.
Bringing it right into the inside, okay? And that will have a significant difference, impact on the performance of the system. So I'll just show you, this is an example of a project I worked on. The customer called me up and he said, hey, he goes, I'm installing your XT curtain wall, which is our highest thermal performing curtain wall system. And he says, I got condensation and I got frost. This is our highest performing product. He goes, I got condensation and I got frost. There's something that's got to be wrong. And so I started asking him some questions about the project, and he goes, I'm going to send you some pictures. And he sent me 18 pictures. And you know what the pictures were of? Wet metal. Does wet metal, if he wants to tell me he's got condensation, I'll believe him. I don't need to see pictures of condensation, okay? I need to see pictures. I need to see his shop drawings. I need to see pictures of the as-built condition, this type of thing. There were 17 pictures of wet metal, and there was one picture that he took from across the parking lot just to show the building. And I'm looking at the picture, and underneath the bottom of the curtain wall, there's a black line. Okay, bottom of the curtain wall, there's brick, but between the bottom of the curtain wall and the brick, there's a black line. And I said, what's that black line at the bottom of your curtain wall? He goes, what the hell are you talking about? There's no black line at the bottom of the curtain wall. I said, look at picture number 17. Okay. He looks at it, he goes, oh. He goes, well, that's the brake metal. I go, okay. I said, where does the brake metal go? Now he knows he's in trouble. He goes, oh, it doesn't go anywhere. I go, what do you mean it doesn't go anywhere? It's just sitting there on top of the brick. I go, how far back under the curtain wall does it go? Well, it really, well, what I finally got out of him was the condition that they had. Okay, they had this brake metal. This is what I saw. It actually came down a little bit lower than that. The brake metal came up here, and then it tucked up between the pressure plate and the mullion. It didn't even come all the way back to the inside. Okay, he just took that piece of brake metal and kind of held it in place by compressing the pressure plate against it. Okay, but what's he done?
Completed. I saw the thermal.
Yeah, he's completed the circuit, hasn't he? Okay, so you look, I had a thermal model made. This is the typical sill condition for this curtain wall product. And you can see 70 degrees on the inside, 0 degrees on the outside. The mullion surface temperature at that temperature differential, the surface temperature is 45.7 degrees. Is that enough for freezing? Okay, but look what happens when all you do is tuck a piece of brake metal into here. 20 degree surface temperature difference because now if he had brought it all the way back in here, it would probably be even lower than that. Okay, so this is something again that we're looking at. You guys are doing projects, and I've worked with your people in here before where they're trying to talk the general contractors and the architects out of putting, how they're dealing with the brake metal underneath our systems, and we're trying to improve on that. But all we can do is warn them. If they still insist on doing it, and then they call us up and they start complaining about condensation, we have to be upfront and tell them that they're kind of inviting that if they're not treating the brake metal properly with regards to perimeter conditions in our mullions. Okay? And we've already kind of talked about expansion and contraction. And again, I think that thermal stuff isn't stuff that you need to know. I just thought it would be good information to help you know a little bit more maybe than you already know.
We're doing a lot more.
Yeah, and you're gonna because it used to be. I remember the first time I came up here to do training. We did training over that old Hampton Inn, and we were there, and you guys, a bunch of you guys, and it was a bunch of your customers too, and the guys that the wholesale customers. And I was talking about the thermal break in one of the systems, and this one old guy comes. He was a really old guy. He comes up to me and he goes, yeah. He goes, that thermal break is just a gimmick, right? He goes, that's just a gimmick for you guys to charge more money for the metal. I go, no, it really works. I wish I'd had these slides to show him so he could see it. But, I don't even know if he would have believed it, but oh well. Okay. Open up your. What kind of sucker was that? What flavor? Orange. All right. So, any questions about anything so far? Well, go ahead and open up your booklets to the YCW 750 OG curtain wall, and we're going to go through this just like we did with the storefront this morning. Okay.
What does OG stand for?
Here we go.
Gangster.
And first of all, what does YCW stand for?
YKK curtain wall.
YKK curtain wall. Okay.
7.5.
7.5. That's the nominal system depth. Of course, we have deeper and shallower mullions. We got deeper and shallower pockets, but the typical depth is 7.5 inches, and the OG stands for
Okay.
Old Gangster. Old Gangster. YCW 750 Old Gangster. I like that. Okay.
I thought it was original.
Yeah. What's it really stand for? Yeah, outside glaze. So we also have a YCW 750 IG. But this outside glaze version nevertheless is still our most popular curtain wall product. You guys know fundamentally the difference between curtain wall and storefront. So storefront is designed to be installed between structural elements in an opening. Okay, is a curtain wall fitting between structural elements typically? It's actually designed to be a curtain of glass and aluminum that hangs outside the building structure. It's attached to the building structure, but it's outside the building structure that allows us to have a continuous curtain of glass and aluminum up the entire height of the building if we want it to go that high. Okay, whereas the storefront is fitting into building openings. Okay, but this is this is the actual product sample for it. You can see we've got some common features here. It is a curtain wall system. It's outside glazed. A common feature for these types of systems is tubular mullions. The horizontals and the vertical mullions and the heads and sills are tubular in terms of their shape. Typically, instead of having a deep, shallow pocket type of configuration, the mullions have a tongue feature on them. And once the glass is set, then we attach pressure plates from the outside to kind of create the glass pocket and to capture the glass. Okay? So those are kind of common features. Then, of course, after we've completed all the steps that we need to complete, and after we put the pressure plates on, we have snap-on covers to conceal the pressure plates and the fasteners. Okay? What do you guys call these things?
We call them beauty caps.
Beauty caps. Yeah. The guys up in New York they just call them beauties. They don't waste the speech on the word cap. They just call them beauties. But yeah, we call it a face cover, and it serves a couple different purposes. One purpose is just to conceal the pressure plates and the fasteners. The other is we're going to have weep holes in this pressure plate that are allowing for the air pressure in the glass pocket to equalize with the air pressure on the outside, and also to allow any infiltrated moisture to drain out. The face cap is protecting that weep hole, preventing air from blowing into that weep hole and preventing it from draining. So the face cap is more than just a beauty cap. It's actually protecting that weep hole so that it can always function. And then, of course, the face cap itself will also have a weep hole to facilitate moisture drainage and pressure equalization. Okay? So these are the typical product details. This is what I would consider, or that we consider, our standard configuration of the product. Okay? And what I want you to notice is, again, we have the tubular mullions. We have this feature on the front of the mullion that we call a tongue. We have these horizontal pressure plates that are fastened onto the tongue of the mullion. What's this red thing right here? It's a gasket, but with its primary purpose, it has actually two purposes. One is it functions as a thermal isolator to thermally isolate the outside aluminum from the inside aluminum. But also, what we do when it's properly applied is it prevents moisture from coming down between the pressure plate and the mullion and getting on top of that lower light of glass. Okay. You'll notice here at the jamb, in the typical configuration, we have an open back member at the jamb. Do you guys use the open back members at the jamb, or do you use the tubular members at the jamb? A little bit of both. And we offer that. That's some versatility that we have with this product. Sometimes people prefer to use the tubular members at the jamb, the head, and the sill. Sometimes they prefer to use the open back members. Doesn't matter to us. You can do it either way. There are a couple of things that are a little bit different if you do one versus another. And my personal preference is for the open back member at the perimeters, because I like being able to caulk to this little leg, number one. And number two, it allows us to use the exact same pressure plate everywhere. We don't have a perimeter pressure plate that we have to fabricate a little bit differently. So I like being able to use that same pressure plate everywhere, and I like having this leg right here for us to be able to caulk to at the perimeter. Okay. Also on here, what are these things right here?
Shear block.
That's a shear block. Those are the fasteners for attaching the shear block to the verticals. We have fasteners for attaching the horizontal mullions to the shear blocks. What's this black thing right here?
Satin block.
Okay, and our interior and exterior glazing gaskets, like the storefront, we use the same gasket inside and out for most applications. If we do the SSG application, we have a thicker gasket that we use on the inside and a thinner gasket that we use on the outside. Okay? And then here you can see the weep hole in the pressure plate and the weep hole in the face caps. Okay?
I see some new pressure plates out there. I mean, beauty cats that have like, you put like a straw, it looks like, through the weep.
That's the polyamide pressure plate I was talking about before. The black ones,
Yeah,
right?
and it has like a washer we're actually putting behind. So
Mhm.
like,
After we get through this, we'll take a break. And then one of the last things I want to talk to you about is that polyamide pressure plate, just so you know what it is. And again, understand where that's coming from. That polyamide, the evolution of that polyamide pressure plate is a function of people trying to find more and more ways of improving the thermal performance. Okay? And like I said, I'll do another presentation after this and we'll talk just about the polyamide pressure plate. Okay? Any other questions about these details? Okay? So of course we have our installation instructions, just like the introduction stuff that we talked about with the storefront when we started. Make sure you've got the most current set of installation instructions. The basic layout is kind of the same. We've got our basic installation notes. We want everything to be installed plumb level and square. You'll see that with this particular system, the way we anchor it, the actual leveling and squaring of it's a little bit different than what we do with the storefronts. Sealant, adhesion, and compatibility, the same kinds of issues as with anything else. We're not going to tell you what kind of sealant to use. We're going to show you where it needs to be applied, and then it's reliant on your good craftsmanship and workmanship to make sure that it's functioning properly. Okay. Same thing here. We want to make sure we're isolating the aluminum from steel and masonry or any other incompatible materials for the same reasons that we talked about with the storefront system. Okay. And then you've got here the parts identification section. And again, this particular page, this mullion right here, these mullions on this side of the page are for 1/4 inch infill. The mullions over here on this side of the page are for 1 inch glazing. And you can see that in the description of the actual part. Okay, and then of course we've got our pressure plates, the face caps. We see we've got some special adapters for corner conditions. All of that stuff is shown right here in the installation instructions. Okay. And then of course we got a bunch of accessories too. One thing in particular that I want to show you on the accessories is what are these things right here?
2.5 anchors.
What are they for?
Anchoring the curtain wall.
Yeah, that's how we're ultimately going to anchor the curtain wall at the top and the bottom, right? And these fit down inside the top and bottom of the vertical mullion. What I want you to notice here is on the part description, this mullion T-anchor. Notice we have more than one T-anchor, okay? They come in different sizes based on the sizes of the mullions. And we want the T-anchor to fit properly inside the end of the mullion. We don't want it to be so loose that it rattles around, and we don't want it to be so tight that you have to try to drive it in with a mallet. There's a right size. And so you'll notice here that this T-anchor is for specific mullions, and those mullions part numbers are listed there. This one is for, again, these are all for particular mullions. So when somebody is ordering this material, they need to be making sure that they're keeping their eye on the ball and ordering the T-anchors that are going to fit the mullions that they're ordering. Okay?
Yeah, I have a recommendation of that.
You have a recommendation?
Is to somehow put a part number on that,
On what?
on the T anchor.
Stamp them.
Oh, stamp them on the T-anchors.
Somehow.
Or
Because we have problems all the time. A lot of our jobs have mostly all the same, and then like 5 or 6 oddball sizes for like a certain special corner. A lot of times we're doing OG curtain wall with just an SSG corner. Well, now I have 2 special T anchors for that. They all get put in a big box, and then I forget which ones are what.
Yeah.
Without measuring each one, and they're so close in size that even then it's sometimes difficult.
That's a good tip. I'll look into seeing if there's something we can do there.
That's a common problem for us. Is
Okay.
having
Color code them, spray paint.
Color code them, spray paint them. Yeah. What finish? What color are these usually?
No.
Yeah, we don't usually finish the TNF anchors.
No.
They're not in an area where they're going to be exposed to the elements usually. They're not going to be in an area where they're going to be visually seen, right? So we just leave those mill finish, a lot like we do the thresholds on our entrances, right?
Sheer block people.
The shear blocks are mill finish also, yeah. Okay. And then of course we've got all the other accessory items, the joint plugs, all the different fasteners, the mullion end caps, the gaskets, all those kinds of things are listed right here. Just as general information notes, is it possible that you could install a curtain wall in what might normally be a storefront opening?
Yeah.
You probably do it all the time, don't you?
Uh-huh.
Okay. Yeah, the reason that you're doing that is because usually it's occurring when you have actual curtain wall on the project, and then you've got other openings that are smaller. And the architect wants the glazing system to match. Okay? So if you might even have punched openings where you're putting curtain wall mullions in. Okay? Now on the other hand, can you install a storefront system where you might normally install a curtain wall? Yeah.
They're good, but you shouldn't.
Yeah, you probably could, but you definitely shouldn't. Okay. So what we're showing here are different kinds of openings and how the curtain wall systems might be installed. So in this particular case, what we call a single span application, that's where we have mullion end anchors only. Okay, and so all of the mullion deflection has to be managed between the mullion end anchors. Okay. We also have a condition like this that we call a twin span application. We have mullion end anchors at the ends, but then we have something breaking the span in between that allows us to attach a wind load anchor from that whatever that structural element is. In this particular case, they're kind of indicating that it's a floor slab, right? But what have you guys got out here in your lobby? You have something like this.
Steel.
You have steel beams out there. And then what we're doing is we're reducing the span between the top and the bottom. So if you're looking at like this opening right here, this might be 24 feet long, right? That's a lot of span to have to control the deflection of that mullion. So by having this structural element at the midpoint, we can bolt it to the mullion. Now instead of having one 24-foot span, what have we got? We have twin 12-foot spans. That's where we get the term twin span, okay? And controlling the deflection in a 12-foot mullion is much easier than controlling the deflection in a 24-foot mullion, okay? Can you install a 24-foot single span?
Yes.
What do you got to do?
Reinforced.
Steel.
You're probably going to have to get big, the 10-inch deep mullions and pack them full of steel, okay? So it can be done. Then you take it to the next step, which is the ultimate, what curtain wall systems are designed to be able to do is a condition that we have called multi-span. That's where you're spanning however many floors you want to, going all the way up the building, okay? How long are our vertical mullions that we sell you guys in stock length form? 24 feet. So if you guys, somebody in your estimating department hits a home run and you guys land a curtain wall project that's for a 400-foot tall building, are we going to extrude you 400-foot long vertical mullions? Now, what are we going to send you?
Splice them.
Well, we're going to send you truckloads of 24s and a box full of splice sleeves, right? So when you're talking about the potential height of a curtain wall, okay, we still require structure to attach to. But remember, the mullions themselves are spanning multiple floors, but they're attached at the floor line. So you can see here, we still have a mullion end anchor at the bottom. As we come up, we've got a wind load anchor, and then we've got another wind load anchor, and then we've got something called a what? Well, before we go there, what's this right here?
Splice joint.
So that's the limit of the length of this mullion. But we want to keep going up, don't we? So we have a splice joint. So you remember how we were splicing the sill flashing, right? So we can go that way as far as we want to. Well, with the curtain walls, we have to be able to splice the vertical mullions so we can go that way as far as we want to go. Okay? So we have a splice joint here. Now, up above the splice joint, we have a what?
Dead load.
A dead load anchor. Okay? Now, what the wind load anchors and the dead load anchors are doing is they're preventing the mullions from deflecting in and out where we have structural attachment. That's their primary function. And we'll talk more about the wind load and dead load anchors as we get a little further into this. Okay? So any questions about the different ways that you can use a curtain wall? Okay? So what this product, this YCW 750 OG product, is what we call a stick erect curtain wall. What does that mean? What does stick erect mean?
Build in pieces.
What's that?
Build now and feel piece by piece.
Yeah, basically the intent, and again, this is the design intent behind the product, is that we ship you truckloads of 24 footers, right? And we ship you boxes of screws and accessories and joint plugs and gaskets and all that stuff. You guys take all that material, you go to the saw, you cut the mullions to the size that you want, you drill holes in them, you attach shear blocks to them, and after you've done all that stuff, you take all those things, all those sticks, and you bundle them together, load them on a truck, and take them to the job site. And then the intent is that it is then erected stick by stick. So what you're doing is you're anchoring the mullion at the top and the bottom, then you attach, and your wind load anchor, and then you attach your sill and your horizontal mullions and your head mullion, and then you bring in the next vertical mullion and you attach it, and you keep going on down the building, erecting it stick by stick. Okay? That's the design intent. The reality of it is that a lot of you guys, what you're doing is you're pre-assembling this ladder, let's call it a ladder, in the shop and taking it out to the job site already assembled. Do you guys do that?
We don't do that anymore.
You don't do it anymore.
No,
We used to build a section, knock down a section, build
Yeah.
a section, knock down a section. And stand up one, put the pieces.
Yes, so you'd have some of the bays be pre-assembled, and then you would do the adjacent bay KD, and then you bring in. So you don't do this anymore.
We found that shipping it like that was too difficult. I think we probably would if it was like a small job.
Yeah.
We would maybe consider it again, but
Okay.
anymore, it's easier to keep track of stuff by just sending
Yeah.
those.
In this day and age, we have more and more people wanting to do as much as possible in the shop. So we're actually seeing more of what you're doing less of, in general. Not to mention.
Also, we never have the machine to lift it if it's too heavy.
Well,
to lift up.
yeah. That's the other thing I was going to get into. So the only point I want to make about that is we recognize that that's common and that's happening, and there's really nothing wrong, theoretically with doing it that way. However, just as a be aware of this type of thing, when you're assembling these frames, there is a very critical seal that has to be performed where you're putting sealant around the front of the shear block when you attach the horizontals to them. Okay? Do you know the seal that I'm talking about?
Yeah, we do.
Okay. Yeah, I know you do that. But the concern that we have is when you build these, you mentioned that you stopped doing it because they're too big and too heavy. The problem with that is when you're moving it in the shop to the truck, when you're getting it from here to the job site, when you're getting it off the truck and then lifting it into place, at any point in that process, if you rack that frame, what have you just done to those seals? You can damage the seals and not even realize you've done it. Okay? And so the only point that I'm making in telling you this is if you want to pre-assemble these things, it happens all day, every day. All I'm saying is make it part of your culture to make sure that you're careful in how you're handling these things. And with this particular system, with these tubular mullions, they're very, very heavy. We have another system. If you guys used our screw spline curtain wall, okay, that is designed to be pre-assembled, and it's much lighter. And by virtue of the fact that you've got screw spline joinery instead of shear block joinery, we tend not to have problems with that joinery, even if you rack it a little bit. Okay, so there is that. If you guys haven't used this, I don't know why we don't sell more of the screw spline product. If I was installing a lot of curtain walls, I'd rather be. You guys like screw spline fabrication better than shear block fabrication?
So here's a question. You said it's lighter, but
Yeah.
does that mean it's also weaker? So then you reach your
No. Well, no. It's lighter because we're using open back mullions rather than tubular mullions. When you put the two mullions together, as you do when you're assembling it in the field, you get very good resistance.
Okay.
I would say the biggest on the relative to the screw spline curtain wall, I would say if you're comparing using it on one job to another, there are some differences. Let's put it that way. The screw spline curtain wall, when you've got the split mullion, you don't have the capacity for steel that you do with the
that's the thing.
tubular.
So a lot of our stuff is single span,
Yep.
but it's 20 to
Right.
30 feet tall.
So if you're doing that, then the screw spline, we do have the ability to put steel inside the screw spline curtain wall, but the geometry of the extrusions makes it much more limited than you have with the tubular. So that's item number one. Item number two, let's say you're pricing a job and you price it with the shear block curtain wall system. And the salesman comes in and says, hey, you guys ever thought about using the screw spline curtain wall? Why, no, we haven't ever thought about that. Well, why don't you let me price this same job for you using the screw spline curtain wall? The screw spline curtain wall price is higher. And the reason is because instead of having a one-piece tubular mullion, what have we got? We have two. That means two dies, two trips to the extrusion press. So there are built-in cost things that make it more expensive, okay? The question is, how well do you understand your labor? Because most of our customers will more than make up for the cost of the material by the fact that the labor for fabricating screw spline curtain walls is so much cheaper, okay? So it's a question of understanding the price difference between the shear block and the screw spline and understanding your labor enough to know, because most of our guys will go, oh, so you gave me a price of $50,000 for the shear block and it's $56,000 for the screw spline. Well, shit, I'm buying the shear block. Well, wait a minute now. What's your labor to fabricate all this? If he knows and he can compare the labor to fabricate it with shear block versus the labor, he might actually be making more money by having better control of his labor. Okay, so that's the idea with the screw spline curtain wall. And I wish, we have some customers that are very good at analyzing that, going, shit, I'd pay a lot more than $6,000 to go to screw spline, right? You don't have to buy the shear blocks. You don't have to drill and countersink the holes in the horizontals. Basically it's just you're screw splining everything together, just like the storefront system. So again, there's trade-offs like anything else. Okay, but it is designed to be stick erected. If you want to pre-assemble them, you can do it. Just be very careful in terms of how you move those things around and lift them up and all that good stuff. Okay. What we're showing here, anybody ever install it, in this fashion here, where you're using this little, we call this an F perimeter as an anchor.
We've only used that a couple times, and we typically use the F in clips, like in little pieces, not a full perimeter.
Yes. Well, what this is for is if you have a very small opening, like a small punched opening where you're putting the curtain wall system in, you'd run this F perimeter around the opening, and then you stick this in from the inside and put the pressure plate on to squeeze it together, and then you caulk it up, and otherwise it works just like any other curtain wall system. It's just an alternate method of installing it. However, if you're going to install it in this fashion, you do have to notch the ends, the tongue on the ends of the vertical mullion to be able to bypass these F perimeter clips. Okay. The more common mullion end anchor method is using the F and T anchors. This is showing your T anchor. That's going to be used at the typical intermediate vertical mullions. The F anchors are used at the jams. And again, the way they work is the T anchors or F anchors just slide into the top and they slide up into the bottom of the mullions. Okay? And the idea being that when you anchor these down, right, when you anchor these down, they're preventing the mullions, the end reaction of the mullion, from reacting in the opposite direction of the deflection on the interior. So it's managing the end reactions. Okay? Now, do we mechanically attach the T and F anchors to the mullions? Okay, so they just kind of are free, not totally free, but somewhat free to telescope in and out of the ends of the mullions. Is that you understand that, right? And the reason is because when you have multi-story buildings like this, it is anticipated, always anticipated, that there might be structural movement in the building. And so if we take a glass and aluminum curtain, right, and we rigidly attach it to the structure of the building, and the building moves, something's going to break, right? Typically the glass and aluminum will break. So what we have to do is we have to be able to attach these mullions to the building, the structure of the building, in a way that prevents the mullions from deflecting in and out or reacting in and out, but also allows the building structure to move. One of the ways we do that is with the F&T anchors being able to slide in and out of the ends of the mullions as the building moves. Okay? Any questions about that? Okay. And these, again, we talked about this. These are typically mill finish. They're not anodized or painted. Okay. We talked about steel reinforcement. I don't want to get too hung up on this particular diagram, but again, if we have conditions where the mullion is going to deflect more than we want it to, it may be necessary to put reinforcement inside the mullion to keep it from bending too much. And this is just showing if you take a standard steel tube and put it in, how it can be attached. What I do want you to notice on this page, and give me your eyes for just a second, when we do have steel inside the mullions, the steel needs to be attached to the mullions. Now, typically on a project that's large enough to where you have curtain wall with steel in it, you're going to have a PE, a professional engineer doing calcs, and he's going to tell you what size fasteners you need to have, how many they need to be, where you got to put them, and all that good stuff. But additionally, it may be necessary for your shear block fasteners to attach to the steel as well. Okay? For those conditions, you would also need to drill through the mullion, like you normally would for your shear blocks, also drill into the steel and tap into the steel. And then for those conditions, we actually have longer shear block fasteners than the typical ones in order to be able to go into the steel. So this shear block fastener that you're seeing here, this HF2516W1, is a little bit longer than the typical shear block fasteners that we have, so that can be going into the steel. Okay? Any questions about that? Okay? So again, here's your typical vertical. Now here's the typical shear block fastener. There's no steel here. So this is the HF2510W1, and then going back, these are the bigger ones. HF2516W1, that's for with steel. We use the shorter ones for the typical applications. And you guys have CNC equipment for drilling the holes in the mullions, is that correct?
Yes.
Do you also have the plates, the steel plates that we have? We actually have steel plates that can be bought.
Oh, yeah.
Yeah, do you carry those?
Template thing?
Yeah, do you carry them in the field, or do you have them in the shop, or where are they?
In the shop.
Okay.
Some of our guys would go have.
Okay. I'm just making you aware that we have them. Some guys will actually try to make a drill fixture using cut-off mullions and shear blocks and stuff.
Yeah.
I find that those steel plates are much more reliable in terms of getting a consistent location for those holes. Okay. So again, this is just showing attaching the shear blocks at the horizontal mullion locations. The horizontal preps. So the horizontal mullions are going to be cut to the daylight opening dimension. Whatever your daylight opening dimension, that's how long the horizontal mullions are going to be cut. After you've cut the horizontal mullions to length, you need to drill and countersink holes in the horizontal mullions for attachment to the shear blocks. Okay? So what you'll see is this is looking at the horizontal mullion from the front. Okay? This is looking at it from the side. And you can see in the horizontal mullion itself, there's a little V groove right at the location that those lines are. Remember we talked about the V groove? Okay? So what you're going to do is in that V groove, you're going to come in 11/16 of an inch from the end, and you're going to drill these holes both above and below the tongue on the mullion. Okay? And then we have to countersink those holes, right? Remember when we talked about anchoring through the glass pocket of the storefront system? Why were we countersinking that? Yeah, so you don't have a round head or a hex head bolt that you could bump the glass into. So we want to do the same thing with these curtain wall systems where we're countersinking and using flathead screws to attach to the shear blocks so that there's no screw head to maybe bump the glass into. Okay? So those have got to be countersunk. The head and sill preparation. The head and sill mullions are also going to be cut to the daylight opening dimension. If you're using the open back perimeter mullions, that's the standard configuration. That's with the leg that comes out where we're caulking to. You need to drill these clearance holes right here. What are those giving you clearance access to? Yeah, when you install the mullions, you're going to have bolts that have to go through the T and F anchors. This is to give you access to those bolts. Okay, so we have one hole drilled where you have a T anchor, and where you have an F anchor, you're going to have two holes. Okay, so this particular head or sill member would be at a jam bay condition. Okay, your intermediates are all of your mullions at the intermediate locations will just usually have the round hole, unless you have an unusual condition and you have more than one anchor bolt going through your T anchor. Okay, in which case you would need to coordinate these locations with your anchor bolts. Okay, what's this down here? So this is if you're using the tubular mullion at the head and sill. We have to cut a notch in it, right? And what the notch is for is so that you can drop it down over the shear blocks after the fact. Okay? So again, this is the open back member, this is the tubular member, and you have to do it. This is another reason why I like the open back member better. I don't like this notch. And the reason I don't like the notch is because, again, at the head and sill, we're going to be running our perimeter caulk bead right along here. And this is, to me, is a real good surface to caulk to. At the head and sill with the tubular mullion, you're going to be running your caulk bead right along here, which is fine, but what happens when you get to the notch? There's not much to caulk to there, is it? Okay? So in general, I just like this one better. You guys ever have to do these?
Oh, yeah.
Yeah, nobody likes those. The infamous E-slot. That's when you have an end bay condition and you don't have room to swing that lax unit in. So what you have to do is you have to mill out these E-slots in the ends of the horizontals in that last bay so that you can kind of slide them in from behind over the shear blocks. There's some extra stuff that has to occur with, we have a sponge filler that goes in there, an extra sealant, and special joint plugs and all that stuff. Nobody really likes that, but sometimes it gets you out of a pickle. Okay? Let's talk about pressure plate fabrication. This is kind of important stuff. This is keep your eye on the ball stuff, okay? The pressure plates that you get from us, 24-foot stock lengths, right? Mill finish, right? They come with the thermal separator gasket preloaded into the pressure plate. That's nice, right? Who's yawning like that? You okay, man? You all right? Okay. I know this isn't exciting stuff. I'm not, I don't stay up late at night reading about this stuff anymore either. So anyway, the other thing that we do to the pressure plates before we send them to you is we pre-drill the anchor holes in the pressure plates. Do you guys know how far apart they are?
9 inches.
9 inches, okay? Now that's when you get it out of the box, all of that's already done. You got the thermal separator gasket, you got the anchor holes drilled every 9 inches. That's all right out of the box. Now when you guys start cutting it.
We wish we had the other gasket in it too.
What's that?
So we wish I had the other gasket in it too. The 120 that you put
Well,
on the side.
you think so. You think so, but when you're handling these and fabricating them, all of a sudden they start falling out. They get metal chips in them and stuff like that. We had that with the old Conair pressure plates that came with the butyl tape on. And the first thing we would do is peel that shit off.
Yeah.
Okay, but at any rate, These, we need to, after you're done cutting them to whatever size they are, and the cut length is important too. The horizontal pressure plates are going to be cut to a length of DLO minus 1/4 of an inch. Okay? And there's a couple reasons we're cutting. Why aren't we cutting the pressure plates the same length as the horizontal mullions?
Because the rubber sticks out past it.
Yeah, when you typically when you put the pressure plates on, you put the vertical pressure plates on first, and when you torque down those pressure plate screws, the gaskets kind of compress and then they spread. And so there's not really any room. If you were to cut the horizontal pressure plate to DLO, there wouldn't be much room to fit it in. That's part of the reason. The other reason is because, as you'll see, one of the very last steps that we have, what we want you to do is after you've put the vertical pressure plate on and the vertical face cap, you put the horizontal pressure plate on. We want you to seal between the end of the horizontal pressure plate and the vertical face cap. Okay? And part of the reason that we're cutting it short like that is to give you space to where you can actually tool sealant in between the end of the pressure plate and the vertical face cap. And I'll show you that at the very end of the presentation. That's one of the very last things you'll do. Okay? So again, horizontal pressure plate, DLO minus 1/4 of an inch. Now after you guys, and the vertical pressure plates are going to be cut the same length as the vertical mullions. Okay? Now after you get done cutting them, this is important too. You need to also make sure that you have an attachment hole 1.5 inches from the end of the pressure plate. Now given the randomness of your cuts, you might, after you get done cutting these things, verticals and horizontals, you might have as much as 9 inches from the end of the pressure plate to that first fastener hole, right? Mm-hmm. That's too far. You don't get very good compression if your first fastener is 9 inches from the end of the pressure plate. The right number is 1.5 inches. So what you need to make sure that you're doing is probably down where you're cutting the metal, have a drill press set up with a stop at 1.5 inches, making sure you've got those fastener holes 1.5 inches from the end. Okay? And we used to actually say 1.5 inches or less, but one thing I have found out is that less can be bad too. Have you guys ever installed your pressure plates and snapped on your covers and the vertical and horizontal face covers aren't lining up real good? A lot of times that happens when you have less on the horizontal. If you have less than 1.5 inches and you tighten it down, it pulls the end of the pressure plate in too tight, and then the horizontal pressure plate, the vertical pressure plate is out in front of the horizontal pressure plate. Conversely, if it's more than 1.5 inches, then all of a sudden the horizontal pressure plate is sticking out too far. So the sweet spot number is 1.5 inches. Okay? The horizontal pressure plates also require weep holes. Okay, we're going to drill round. What size round weep holes? 5/16. Good. Again, nothing is random. The location's critical. We want to come in 3 inches from the end of the pressure plate. And again, there's a V groove. There's a V groove where the anchor holes are drilled. There are also V grooves above and below that where you can drill your weep holes. Okay? You come in 3 inches from the end and drill a 5/16 inch weep hole. We come in 3 inches from the other end and drill a 5/16 inch weep hole. And then we go right to the center and drill a 5/16 inch weep hole. What's magical about those locations? Why 3 inches from the end? Why not just some other number?
Because the setting blocks block the channel.
Yeah. Where are the setting blocks going to be? Anybody?
3 inches.
Well,
more than
it better not be. No, what we're trying to avoid is, so typically your setting blocks are going to be at quarter points, but what's the closest they can be? You guys remember? We talked about that. 6 inches. You should never have a set. And by the way, I go to a lot of job sites where they got leak problems. I make them take the face covers off, and what do I see right there? A black setting block obstructing that weep hole. Okay? So at 3 inches, unless you've got a 1 foot wide light of glass, you should never have a setting block right by that weep hole. Okay? Now, why the one in the center? Why do we have to have one in the center?
If anything's trapped between the two blocks.
If it's trapped between the two blocks, or what happens when you put weight on that horizontal? It's going to sag a little bit, hopefully not a lot, but it's going to sag a little bit. Where's the low point going to be? Right in the center. Okay? Yes, sir.
Is that 6 inches from the screw spline or from like the DLO, the vertical?
You mean in terms of the setting block location? That would be for the DLO. Yep. Yep. Okay? There's another note up here. Okay? It says, note, if the space between the weep holes exceeds 3 feet, additional weep holes should be drilled to ensure that there is no more than 3 feet between the weep holes. Okay? Again, back to our typical opening sizes. How long are our curtain wall horizontals?
24 feet.
Well, the extrusions are, but what about the actual horizontals in your curtain wall? Yeah, but what ties typical? What would be typical?
4 to 8 feet.
4 to 8 feet, okay? So what we're trying to avoid is a situation like I had happen on a project where they had horizontal mullions that were 11 feet long. Is 3 weep holes in the pressure plate enough? Okay, so what we're saying, now we're giving you a guideline. If you're looking at your horizontal pressure plates and you've got more than 3 feet between weep holes, you need to add another weep hole in there. Okay? That's all this is saying. Okay? Any questions about the pressure plate fabrication? And this is guys, all of these nitpicky sounding things, I've seen jobs leak for these things not being done right. One of them not being done right, 2 of them not being done right. Okay, that's why we're this specific about how this needs to be done. Okay, and this is just a little bit better view of the actual looking at the pressure plate from the front. These are pre-drilled every 9 inches, but you need to make sure there's one 1.5 inches from the ends. Weep holes on the horizontal pressure plates, and again here you can see the profile of the extrusion, the thermal isolator, anchor holes, and the weep holes. Okay. The face caps that snap onto the pressure plates, okay? The vertical face caps are going to be cut the same length as the vertical mullions. The horizontal face caps are cut to a length of DLO minus a 1/16 of an inch. Why are we cutting the face caps a little bit short of DLO? Just like the glass tops, right? So we can snap them on without damaging the vertical face caps. We do need to drill weep holes in the face caps, okay? And again, we are very specific about where we want these weep. By the way, what size are these weep holes going to be?
5/16.
Okay, and we are very specific about where we want them to be located. We want the weep holes located at 3rd points on the cover length. Okay, a lot of people think that it's important to get the face cover weep holes directly aligned with the pressure plate weep holes. That's the exact opposite of what we want to have happen. Okay. So when this diagram, I put together this diagram here, what you're looking at in black is the elevation view of the face cap, okay? And this is showing you at 3rd points where the face cap weep holes are located. In light gray back behind it, that's our pressure plate. And look at where the pressure plate weep holes are. Are they directly aligned? No, we specifically do not want them directly aligned. And the reason for that is because during testing or during extreme wind and rain events, if these weep holes are directly aligned, when you have wind blowing at the front of that curtain wall, whether it's generated by a propeller during a dynamic test in a lab, or whether it's just wind from the beach or wind from a storm, air could blow up through that weep hole. And if this weep hole is directly aligned with this one, that air will slow or obstruct drainage from the weep holes. And if this is not draining up here, what happens to the water in your glass pocket? It's going to fill up and it's going to spill over to the interior. So we specifically want to stagger those weep hole locations. They call it baffling. They actually have a term for it. They're baffling the flow of air. Okay? What they used to do to baffle the flow of air? You guys know what baffles are? You guys ever see those? They were little sponges, and they would put those little they would line the weep holes up, but they would put little sponges in them. Okay, and the sponge was supposed to prevent the water or the air from blowing up through there. But what happens with the sponges?
They get clogged up with dirt.
They get clogged up with dirt, and then all of a sudden they're not working at all. So the alternative is to, instead of putting baffles in the system, we baffle the airflow. Okay? That's the idea. These are your splices for your curtain wall mullion. Again, what I want you to notice here is we have the mullion splice, and then the pressure plate splice, and then the cover splice. We want them to be close to each other because they need to be able to move, but we want to stagger them a little bit in case one or more of the splices fails. Water has to go uphill against gravity and get at the other ones. So that's the theory behind why we stagger the splices. And this is the splicing sequence right here. So you have your lower mullion is installed. We put the sleeve in the lower mullion. We pin the sleeve to the lower mullion. We slide the upper mullion over it. And then we do what? What's this? Anybody know what that white stuff is? Bond breaker tape. Who said that? Somebody that actually knows what bond breaker tape is. What does bond breaker tape do?
Stops three-sided adhesion.
Right. So silicone or any sealant can stretch as long as it's adhering to two surfaces. Ultimately, what we're going to do is we're going to caulk between the upper mullion and the lower mullion. And that sealant needs to be able to stretch as we get movement in that joint. If the sealant is also sticking to the splice sleeve, it won't be able to stretch. And then what happens to the sealant when you get movement? It tears and fails. Okay? So we put bond breaker tape here to prevent the sealant from sticking. Then we can caulk between the ends of the mullion and over the bond breaker tape. Okay? Do we need to caulk all the way around? We do not. I would say the only time you ever need to caulk all the way around is if human beings can look up and see that joint. And in most cases they cannot, because this typically occurs in the spandrel area, behind a wall or behind a suspended ceiling system, and nobody sees it. On the other hand, if it's occurring in an area where people can actually look up and see it, then wrap the bond breaker tape all the way around and go ahead and caulk it all the way around. Okay? We don't need it for performance though. Okay? Because we're going to be controlling all of the air and water from the glass pocket forward. Okay? Then we caulk between the ends of the pressure plate. The face cap also has a sleeve in it. So we're going to put bond breaker tape on the face cap sleeve, and then we're going to caulk between the ends of the face cap on the outside. Okay? What are these things? These are mullion end caps. Okay? Mullion end caps. At the end, when we do our perimeter caulk bead with this system, the perimeter caulk bead at the end of the vertical mullion will either be occurring at this location or out here. If your caulk bead is out here, what has it got to stick to if you don't have a mullion end cap? There's nothing. There's nothing there. Even if you're caulking back here, you don't have much to caulk to, do you? You have the edge of the mullion, but you've got voids where the glazing reglets are. You got a hole in the tongue of the mullion. And so we want the mullion end cap on there so that when you apply your perimeter caulk bead and you tool it, the caulking has something to stick to. Okay? And that's going to be at the top and bottom of each vertical mullion. Those are sealed and fastened into place. When you're ready to start erecting your framing system, again, we're going to anchor through the T and F anchors. What's this right here? So what I'm showing you in this diagram is that when you are shimming this, and by the way, you're going to need to shim it at least 1/4 of an inch, because our typical perimeter caulk bead for curtain walls is 1/2 inch. How thick is this plate? So you're going to need to shim it at least 1/4 of an inch, and probably even more than that to get it level. Okay? But the proper way to shim it is the T and F anchors sit down hard on the substrate, and then the shimming occurs between the top of the T and F anchor and the bottom of the vertical mullion. Okay? Any questions about that? We do not want you shimming underneath the T and F anchors or on top of them. We always want to make sure that we're shimming. I didn't mean on top of them. I mean at the head on top of the T and F anchor. We want you to shim on top of it underneath the vertical mullion. Okay? This is what we're showing where you have an entrance door the vertical mullion going all the way down to the floor, and we're anchoring it with a shear block rather than the T&F anchor. These are your wind load and dead load anchors. Okay, this is where we're attaching to the floor slabs as we go up the building, or to steel beams like you have out here. This is a wind load anchor. What do you notice about the attachment hole for the wind load anchors?
Slotted.
It's slotted. When you see a slotted hole, what is that telling you?
It's a wind load.
Well, it's telling you that it's allowing movement, but it's allowing movement up and down. It's not allowing movement in and out. So what it's doing is it's preventing the mullion from deflecting in and out, but it's allowing the floor slab to move up and down relative to the curtain wall. Okay? This one down here is a dead load anchor. What do you think about those holes? They're round. So what they're doing is they're actually carrying weight. They're distributing the weight of the curtain wall back to the structure of the building. We don't want the entire weight of the curtain wall all piled up and going down to the ground underneath the bottom of it. Where at each dead load anchor location, we're going to be distributing the weight back to the structure. And then, of course, we also have the nylon slip pads that we're going to put in between the wind load and dead load anchors and the mullions. What are the wind load and dead load anchors typically made out of?
Steel.
And what do we know about steel and aluminum? Yeah, not good. So we're gonna insulate the aluminum mullion from the steel anchor with these nylon slip pads. An accessory. They're white. They come in a bag of, I don't know, 25 or 50 of them, however many it is. And basically, when you're drilling the hole through the wind load anchor and through the mullion, you slide this in and drill through it. And then when you bolt through it, it just stays there between the mullion and the wind load or dead load anchor forever. Okay? Any questions about that?
Do you guys suggest a rating on the bolt grade, or do you just, like, you don't have any specs for, say, it has to be a grade 8 or?
No, nothing like. A lot of times that's the structural engineer or the PE that's going to make that determination. We do have some guidelines, recommended guidelines for torque on those bolts. That's because one thing you need to remember
It's a hollow tube.
is that it's a hollow tube, but don't forget, we need to allow this to move. If you make that bolt too tight and it restricts movement, a lot of times it can just be a relatively minor problem like grinding and popping noises, but it can also restrict movement that can lead to bigger problems. So I think we have a torque of 90 inch-pounds on those bolts, but in the field, if you don't have a torque wrench, typically what I see the guys doing is, you notice you'll have a flat washer and you have a split washer and the nut, right? You know how the split washers are, they're kind of, or lock washers is a better way of calling it, is when as you're tightening this bolt or tightening the nut on, watch the lock washer, and once the lock washer is flat, give it another quick twist, and that's enough. Okay? You don't want to over tighten. At the jam conditions, we can't bolt all the way through the mullion, can we? Okay? So what we have to do is we have to use what we call a tap plate at the jam mullions, and what we're ultimately going to do is attach the tap plate to the mullion with these little screws here. The tap plate has holes that are tapped, and we're going to bolt into the tap plate at the jam conditions. When we're starting to assemble the frame, whether that's done in the shop or done in the field, again, we're going to take our little rag and our isopropyl alcohol, and we're going to wipe around the front of this, and we're going to apply sealant so that when we slide this horizontal over the shear block and run these fasteners through, that sealant is effectively sealing the seam between the vertical and the horizontal. That's sealing the glass pocket. That's isolating the glass pocket from an air standpoint from the inside of the building. Okay? So you got to seal, and that's done. That seal around the front of the joint, or the front of the shear block, is done at every vertical to horizontal joint. There's your E-slot seal. If you're interested in seeing that, that's in here as well. Door framing, the perimeter caulking. After you've got all your vertical mullions installed and all your horizontal mullions installed, before you start setting glass, that's a good time to do your perimeter caulk bead. And all I want to show you here is with this system, you have two different options for the perimeter mullions and two different requirements for the perimeter caulk bead. If you're using the open back mullions that have this leg on the front of it, this location right here is your dry line location for your perimeter caulk bead. Okay? That is absolute. You can't. Now, if the architect wants you to put 3 or 4 caulk beads in here, that's all well and good. Anything you do has to be in addition to this. In other words, you can't skip this caulk bead and do 4 caulk beads back here. This one has to be here no matter what. Okay? That's generally not a problem. The other option you have is if you're using the tubular mullions, then your perimeter caulk bead is right here at the edge of the mullion. Okay? If you're not caulking to the pressure plate, you're not caulking to the pressure plate gasket, you have to caulk it right to the mullion. Okay? And again, that's your dry line caulk bead, so it varies. Tubular mullion, the caulk bead is here. That's at the sill, at the head, and at the jambs. Open back mullions, your caulk bead is going to be right out here in the front. Okay? Do we need the interior caulk bead? Not for curtain walls. We need it for the storefronts and the window walls. We do not require the interior caulk bead for the curtain walls. It's not part of the performance. A lot of times you end up doing it in some locations because otherwise it's wide open and they just want it caulked up. So whether you guys do it or the painter does it or whatever, we don't require this caulk bead for performance. Okay? Joint plugs. You guys install joint plugs, please?
Yeah.
Okay? So the joint plugs are made out of the same peroxide cured EPDM compound that the gaskets are made out of. So what you're going to do is you're going to clean out that little space there between the vertical tongue and the horizontal tongue. We put sealant on the joint plugs, slide them in there, okay, and then puts a little bit more sealant around them and tool them. Now what I've seen some guys do is they'll put like a skin of sealant over the joint plug, and that's okay too. All I care about is that the joint plug is effectively sealed. Now what I want you to watch out for is there's a glazing reglet that runs up and down the vertical mullion back behind the joint plug there. Make sure you're getting sealant into that glazing reglet. We cannot allow air or moisture to migrate up and down that vertical pocket. Okay? That's the whole purpose of the joint plug. Okay? Then of course make sure you seal your screw heads in the glass pocket as well. Okay? And the joint plug goes at every joint. Vertical, horizontal, head, sill, everything. Okay? Any questions about that? And this is just, again, showing a little bit better view of it. One thing I want you to guard against is the old, if a little bit of silicone is good, a lot of silicone is better. But one problem I have run into on many occasions is guys will come in and they know that this is a sensitive location in the system, and they kind of overcompensate by putting a great huge wad of silicone right here. Then the problem occurs when they come to set the glass in and the corner of the glass is bedded in silicone right here. What's going to happen is any water that gets in the vertical pocket will be trapped. It won't be able to get to the weep holes, and it'll build up inside the vertical pocket until it finds a weak spot and starts dripping through on the inside of the vertical mullions. Okay? So I'll show you later on. After the glass is set, you should be able to see that this is open between the edge of the glass from the vertical pocket down to the horizontal pocket. Okay? Watch out using too much sealant. Like this. Okay? That was bad. Or this. What's wrong here?
No seal.
So he didn't put any sealant on it. Okay? So I gotta go to pictures. You don't want me putting your pictures in my presentations, okay? And this is, again, most commonly what I see. If something is done wrong around the joint plug, in the vertical to horizontal joint, or the screw head, that allows a path of water to get inside this horizontal tube. And so if you're starting to see leaks underneath your horizontal mullions like this right here, whether it's a leak or it's water stains, that's telling you that water has gotten inside this tube. The only path that the water has to take to get in there is through this area right here, those yellow areas. So if you've got water, the aluminum is not porous. The water's not going through the aluminum. What's it going through? These areas here that need to be sealed. Okay? The gaskets, the vertical gasket is cut to a length of DLO plus 1.5 inches. Horizontal gasket is DLO plus 1/4 inch per foot. Don't stretch them to fit. We want the vertical gasket to run through and the horizontal gasket to butt up to it. Okay? After you've got the gaskets cut to size and pressed into the mullions, we want you to peel that vertical gasket out, and you're going to run a bead of sealant in the glazing reglet up 3 inches in that reglet, and then press this gasket back down into it. And then you're going to do the same thing horizontally. You're going to peel the horizontal gasket out, run sealant in that reglet across 3 inches, and then also put sealant on the end of the horizontal gasket, press the horizontal gasket into the vertical gasket, and then press the gasket into that reglet, and then tool off the excess sealant. That's at all 4 corners of each light of glass. Okay? These are the reglet seals I'm talking about right here. And then, of course, the gaskets get pressed in, and we seal between the end of the vertical gasket and the horizontal gasket. And again, make sure you're tooling off any excess sealant there. Okay? Setting blocks go in at 1/4 points, no closer than 6 inches from the, I said from the daylight opening, didn't I? Mm-hmm. It's not from the daylight opening, it's actually from the edge of the glass, okay? Which is a difference of 3/8 of an inch, or 1/2 inch, okay? We have side blocks that go in, again, to keep the glass from shifting side to side. And again, this is the diagram I was showing you. If you've put so much sealant on your joint plug that this glass is setting in sealant, that's too much. The water has to be able to get from the vertical pocket down here to the horizontal so it can come out the weep holes. Okay? Before you start putting your pressure plates on, the full pressure plates, these are temporary retainers to hold the glass in place. Before you start putting the full length pressure plates on, you need to put sealant on the front of the joint plugs. That way, when you torque the pressure plate screws down, you're applying sealant here so that that's completing the seal on the joint plug. A lot of people miss putting the sealant on the front of the joint plug. If you don't seal the front of the joint plug, water that's in the glass pocket can go between the joint plug and the pressure plate and get on top of that light of glass. Okay? So don't forget to put sealant on the front of the joint plug.
Is that before you put the vertical on?
Right before you put it on. So that should be wet when you put the vertical pressure plate on. Okay? Again, fasteners, we need to make sure when you're screwing these things on, just these are kind of some things that you need to pay attention to. Make sure you have fasteners 1.5 inches from the end of the pressure plates. There should be 3 weep holes per horizontal pressure plate for normal size pressure plates. Make sure that the weep holes are positioned above the fasteners, okay? Every time I go to a job where there's a sizable curtain wall job, if I'm out there before they've snapped the covers on, I will find at least 1 pressure plate installed upside down. Every time, okay? And if that horizontal pressure plate's upside down, it's not going to drain and it's going to leak and all that good stuff, okay? We do have torque requirements. Initial torque, when you first put the pressure plate down, you should be snugging it down to about 30 inch-pounds. After this, it's just like when you change a tire in your car. When you put the new tire on and you put the lug nuts on, when you put that first lug nut on, do you go dead tight with it?
No.
Now, what do? You snug them all up to make sure it's all even, and then you go to your ultimate tightness, okay? Same concept with these pressure plate screws. So we want you, initial torque is about 30 inch-pounds. Final fastener torque is 50 inch-pounds, okay? You guys, I've talked to the guys yesterday. You guys don't have any method for managing torque on these things, do you? Okay? That's something you need to look at because I'm running into more and more problems with the torque being an issue. And it's not that they're not making them tight enough, it's that they're making them too tight. And the reason for that is because of these damn impact drivers. Okay? I think an impact driver is a great tool for running a Tapcon into concrete. It's not the best tool for assembling aluminum products. Okay? Especially if the user doesn't have respect for the amount of torque he's holding in his hand. Okay? So again, what I'm seeing with the pressure plate screws is guys are out there, they're sticking the screws in, and they're sticking that impact driver on, and they're just ramming them. And they're going to the neck, they're doing it real, real fast. The problem is when they're doing it, they're stripping out at least half of them and not even realizing it. And if you're stripping out the pressure plate screws, guess what? You're not getting very good compression. So I'm just giving you a heads up. How you guys choose to manage it is up to you. They have torque limiting devices that you can put on your screw guns, or you can have somebody that's responsible for checking the torque that you're getting and adjust. And some of you guys have, is that
That's a clutch on it.
is that an impact driver?
No,
That's just a screw gun.
yeah, that's just screw gun.
Yeah.
That's what we used to.
So
That-
I wouldn't say that we don't have a we
Yes,
don't have a way to be very accurate about it, but we're not.
but you can manage it as long as you're managing.
Like one or two of them on jobs, and then everybody with a clutch gun or whatever, because each brand was a little bit different than the other.
Well,
When
yeah,
somebody
we
put it in a
found
torque one,
those
you would use
clutch
that
guns-
drill, so it worked to the
Yeah,
same
those
thing.
clutch
as
guns,
that.
me and Ty used them at BMW, and I found that when you crank them down to be light enough to match this, they were inaccurate. One would be too tight, one would be too loose. And
Yeah.
it was like they were very inconsistent.
Well, we used to have torque guns.
It's some torque, right?
I think
Well-
they would run a little too far on you plug them into the iReach lift or something. Yeah.
Well, I've talked to some of the people at your company, and there are manufactured a torque limiting device, and you take your little extender piece, stick it in your driver, and this thing snaps onto it, and then you can put your 3/8" nut driver on that. And there's two different kinds you can get. One of them is adjustable. Conair sells one. They have a part they actually sell. Theirs is adjustable. You can also buy them from MSC and Grainger and places like that. And they're not cheap. I mean, it's a tool. We're talking $200-300 for one of these things. Okay? And it's adjustable. The problem with the adjustable ones is you have to check them periodically, and then if your torque is changing, you have to take them apart and readjust them, and that takes time. There's another company in Massachusetts called Seekonk, and they actually manufacture torque limiting devices that can be set at a specific torque. And those are kind of cool because you get them. It comes in a box. It looked like when my daughter bought me a Harry Potter wand. Oh, geez, I've got my wand. It comes in a box like that, and it's got a certificate in it telling you what the torque's been set to and how they checked it. And then once a year, you can send it back to them, and they'll check the calibration on it and reset it. So how you do it is up to you. My caution is about making sure that you're doing something, because the biggest problem I'm seeing is over torque. Okay, not so much under torquing, but over torquing. Usually under torquing occurs when you have those old screw guns. Remember the old ones when the battery would start going dead, and instead of getting a new battery, you'd hold the trigger in and kind of twist it to tighten those screws. You have no idea how tight they're getting. You just don't know. Okay, so at any rate. Also, if you're using the offset pressure plate with the tubular mullion, don't forget to put the isolator tape in there. Okay? Don't forget the isolator tape. After that, after you got the pressure plates on, you can snap on your vertical pressure plate. And remember I said, what was the cut length on that horizontal pressure plate?
That's the 16th.
No, the pressure plate, not the cover.
Less than a quarter.
It was less than a quarter. So you should have about an 1/8" gap here between the end of the horizontal pressure plate and the vertical cover. And we want you to apply sealant in there and tool it in. Okay? After you've done that, you can snap those horizontal covers on, and it's Miller time. The other thing I wanted to show you here, we'll take a quick break in a minute before I talk to you about the polyamide pressure plates, and then we'll be done. But if you're using the deep covers, when you get the standard covers, they snap on pretty good and they stay in place. Our extrusion tolerances are good. And the other thing is, when you're talking about a snap-on cover and a mill finish pressure plate, you've got pretty good friction there. Okay. However, when you get to the optional deeper covers, you're adding more weight. They have a tendency to expand and contract and maybe move out of place, if not just gravity pulling them down. So when you have the deep covers, we have an optional pressure plate that has these long flanges on it. Do you see that? And that allows you to pin the face cover to the pressure plate to prevent that up and down sliding. Okay? So if you got the deep covers, don't forget to buy the optional pressure plates that go with them. Okay? Let's take a quick 10-minute break, and then I'll walk you through this poly-mic pressure plate. Okay?
And then it was another 6 inches. I was like, what the fuck? That's crazy.
Oh, so you just have like a face value now?
This is the aesthetic look.
That's crazy. It's cool to actually see the amount of water.